I see that the precision for class 1 is 0.8. This means, out of all the instances the model predicted as class 1, 80% were actually class 1. It's a measure of how accurate our positive predictions are. Pretty good. This section presents a multiple-choice question based on the performance metrics of a scikit-learn classification model. We will analyze the model's performance to see which statement is correct. The recall for class 1 is 0.6. This tells me that the model correctly identified only 60% of the actual class 1 instances. It measures how well the model finds all the positive instances. This is the core question. I'll evaluate each statement using the provided metrics. For class 0, the precision is 0.7. This means 70% of the instances predicted as class 0 were actually class 0. The recall for class 0 is higher, at 0.8. This means the model correctly identified 80% of the actual class 0 instances. The F1 score for class 0 is 0.75. Remember, the F1 score is the harmonic mean of precision and recall, giving equal weight to both. A higher F1 score suggests a better balance between precision and recall. In this case, class 0 has a better balance than class 1. This is the core question. I'll evaluate each statement using the provided metrics. The overall accuracy of the model is 0.73, meaning it correctly classified 73% of all instances. The macro average F1 score is 0.725. This is the average of the F1 scores for each class, giving equal weight to each class. It can be a better indicator of overall performance than accuracy, especially in cases of class imbalance, where one class has significantly more instances than another. The recall for class 1 is 0.6. This tells me that the model correctly identified only 60% of the actual class 1 instances. It measures how well the model finds all the positive instances. This is the overall theme of the problem. I will evaluate a scikit-learn model's performance using the given classification report. This section details the specific metrics used to evaluate the model's performance: precision, recall, F1 score, and accuracy. We'll use these metrics to interpret the model's capabilities. Statement A suggests that the model performs better on class 0, negative, than class 1, positive. I need to compare the metrics for both classes to verify. Statement B claims the recall for class 1 is higher than its precision. I'll check the values from the report to see if this is true. Statement C proposes the macro average F1 score is a more suitable metric than accuracy because of potential class imbalance. I will consider the possibility of imbalance and compare the macro average F1 score with the accuracy. Statement D suggests a better balance between precision and recall for class 0 compared to class 1, due to a higher F1 score. I'll compare the F1 scores of the two classes to validate this. I'm analyzing a classification report generated by scikit-learn, a popular machine learning library in Python. This report summarizes how well a model performs at classifying data into different categories. This section presents the key performance metrics for a binary classification problem: 2 categories, 0 and 1. I'll use these numbers to evaluate the model's effectiveness. Out of all the instances the model predicted as class 1, 80% were actually class 1. This is the precision for class 1. Out of all the actual instances of class 1, the model correctly identified 60%. This is the recall for class 1. The F1 score balances precision and recall. It's the harmonic mean of precision and recall for class 1, and here it's 0.7. A higher F1 score is better. Similar to class 1, but now for class 0, 70% of what the model predicted as class 0 was actually class 0. The model correctly identified 80% of actual class 0 instances. The F1 score for class 0, balancing precision and recall, is 0.75. Overall, the model correctly classified 73% of all instances, regardless of class. This is a simple, but potentially misleading, measure of performance. This averages the F1 scores for both classes equally. It can be more informative than accuracy when classes are imbalanced. Here, it's 0.725. I'm analyzing a classification report generated by scikit-learn, a popular Python library for machine learning. This report summarizes how well a model performs in a classification task. We're looking at several key metrics: precision, recall, F1 score, and accuracy. These tell us different aspects of the model's performance. Precision measures the accuracy of positive predictions. Recall measures the model's ability to find all the actual positive cases. The F1 score balances precision and recall. Accuracy is the overall correctness of the model's predictions. For Class 1, one of the two categories in this binary classification problem, the model has a precision of 0.8, meaning 80% of its positive predictions were correct. The recall is 0.6, meaning the model correctly identified only 60% of the actual positive instances. The F1 score combines these, and is a bit lower at 0.7. For Class 0, the model's precision is 0.7 and its recall is 0.8. This means it is slightly better at recalling negative instances than at precisely predicting them. Its F1 score is 0.75, which is slightly better than that of Class 1. The overall accuracy of the model across both classes is 73%. The macro average F1 score is 0.725. This is the average of the F1 scores for Class 0 and Class 1, treating both classes equally in importance. I'm presented with multiple choice questions to assess my understanding of the classification report. This statement is true, but requires qualification. While the F1 score is higher for Class 0, I don't know if there's an imbalance between the number of Class 0 instances and Class 1 instances. If there is an imbalance, a higher F1 score for the majority class doesn't necessarily reflect better overall predictive performance. It's a bit tricky. This statement is false. The recall, 0.6, for Class 1 is lower than its precision, 0.8. This is potentially true, but cannot be definitively confirmed without knowing the class distribution. If the classes are imbalanced, the macro average F1 score might provide a fairer comparison than the overall accuracy. This statement is definitely true. The F1 score of 0.75 for Class 0 is higher than the F1 score of 0.7 for Class 1, showing a better balance between precision and recall for Class 0. I'm analyzing a classification report from Sklearn, a popular Python library for machine learning. This report summarizes how well a model predicts class labels. Specifically, I'm focusing on a binary classification problem, meaning the model predicts one of two possible outcomes. I'll be looking at metrics like precision, recall, and the F1 score to understand the model's performance. Let's dive in. The report provides precision, recall, and F1 score for each class: positive class 1, negative class 0, plus overall accuracy and a macro average F1 score. For example, a precision of 0.8 for Class 1 means that when the model predicted Class 1, it was correct 80% of the time. I will use these numbers to answer the questions. I need to determine which statements are true based on the given classification report. I'll assess each statement using my knowledge of the metrics and their interpretations. The classification report data is the input to my evaluation. I'll process it to assess each statement's validity. Think of it like this: the data flows in, and I use my analytical skills to determine the output, true or false for each statement. I'm acting as the evaluation engine, applying my understanding of precision, recall, F1 score, and accuracy to analyze the given metrics and decide if each statement accurately reflects the model's performance. Think of me as a critical judge evaluating the model's report card. We're evaluating how well a machine learning model, built using the Sklearn library, performs a classification task. Think of it like grading a test for a model. I'll be looking at key numbers that tell us about the model's accuracy in identifying things correctly. We're using a classification report, a common way to summarize how well a model does. Out of all the things the model predicted as belonging to Class 1, 80% were actually correct. Precision focuses on the accuracy of positive predictions. The model correctly identified 60% of all the actual instances of Class 1. Recall focuses on how many actual positives the model finds. This is a single score combining precision and recall. It's a harmonic mean, a way to find a middle ground between the two. It's a good overall indicator for Class 1. The F1 score is 0.7. For Class 0, 70% of the model's predictions were correct. Similar to Class 1, but for the negative class. The model found 80% of the actual Class 0 instances. Again, similar to Class 1, but for the negative class. The combined precision and recall score for Class 0 is 0.75, showing a better balance than Class 1. Notice it's slightly higher than Class 1's F1 score. The overall accuracy of the model, 73% of all predictions were correct. This is a simple percentage of correctly classified instances. This is the average of the F1 scores for Class 0 and Class 1, giving equal weight to each class. It considers performance on both classes equally. Now, let's test your understanding with some questions about the model's performance. I'll present some statements to evaluate. Based solely on the F1 scores, the model appears better at predicting Class 0. However, we must consider potential class imbalances. This is false. The model has higher precision, 0.8, than recall, 0.6, for Class 1. Potentially true, but we can't definitively say without knowing the class distribution. The macro average F1 score may be more representative than accuracy if there is class imbalance. This is absolutely true. The F1 score for Class 0, 0.75, is higher than for Class 1, 0.7. Choose all the statements you believe are correct based on the model's performance metrics. We're evaluating how well a machine learning model, built using the Sklearn library, performs a classification task. Think of it like grading a test for a model. This shows the model's performance. For Class 1, positive, I see a precision of 0.8, meaning 80% of the times the model predicted Class 1, it was correct. The recall of 0.6 means the model correctly identified only 60% of the actual Class 1 instances. The F1 score, a balance between precision and recall, is 0.7. For Class 0, negative, the precision is 0.7, recall is 0.8, and F1 score is 0.75. The overall accuracy is 73%, and the macro average F1 score, averaging F1 scores of both classes equally, is 72.5%. This is the core question. I'll analyze each statement using the provided classification report numbers. Interesting. While Class 0 has a slightly higher F1 score, 0.75, than Class 1, 0.7, it's tricky to definitively say it's better. The difference isn't huge, and we don't know the class distribution. A skewed distribution could influence these numbers. Nope. For Class 1, precision, 0.8, is actually higher than recall, 0.6. Maybe. The macro average F1 score, 0.725, is lower than the accuracy, 0.73. This hints at a potential class imbalance, where accuracy can be misleading. However, without knowing the actual class distribution, I can't confidently say this is true. Yes, this is definitely true. The F1 score for Class 0, 0.75, is greater than for Class 1, 0.7, showing better balance between precision and recall for Class 0. I'm analyzing a machine learning model's performance using the popular Sklearn library. Specifically, I'm focusing on how well it classifies data into two categories. I'm using a classification report to get key metrics to understand model performance. These metrics give us a detailed performance summary. For the positive class, Class 1, 80% of the model's positive predictions were actually correct. The model correctly identified 60% of the actual positive instances. The F1 score, which balances precision and recall, is 0.7 for Class 1. It's the harmonic mean of precision and recall. I will now interpret the classification report's findings. This involves carefully examining each metric and understanding its meaning. This statement is plausible given the higher F1 score for Class 0, 0.75 vs 0.7 for Class 1, but not definitive without knowing the class distribution. I need more information. This is false. Recall for Class 1 is 0.6, and precision is 0.8. Precision is higher. Possibly true, but I cannot say for certain without knowing the class distribution. Macro average F1 score handles potential class imbalances better than accuracy, but we don't have that info here. Interesting. This statement is absolutely true. The F1 score for Class 0 is 0.75, while for Class 1 it's 0.7. This shows a better balance of precision and recall for Class 0. For Class 0, the negative class, I see 70% precision, correct negative predictions, 80% recall, correctly identifying actual negatives, and an F1 score of 0.75.